Welcome back. Thom Hartmann here with you. Don't know if you've been following the ice in the Arctic, but this is a really, really, really big story. If you want to get the latest on it, arctic-news.blogspot.com is probably the best website for, just straightforward, here's the information. And we're seeing that the amount of ice that is formed during this winter in the Arctic so far is so far below the norms over the last 4 or 5 decades that it's literally falling off the chart. In other words, there's so little ice. Now, why does this matter? 2 reasons. Number one, underneath that ice, there are an estimated 1,500 billion tons of frozen methane hydrates. These are this slurry of methane. It's like snow cone. And it's along the shallow floor of the Arctic Sea and around the continental edges. And that methane is being kept stable because the water is cold. And the pressure is reasonably high, but mostly because the water is cold. Now, what does this have to do with the sea ice? If you take a glass of water and you put ice cubes in it, along with water, and stick a thermometer in it, so that you're measuring the temperature at the center of the glass, right? You're measuring the actual water temperature right in, and then you set that glass of water, or pan, it could be a pan of water, actually. A glass of water would be a little more probably. Let's say a beaker, a Pyrex beaker. Set it on top of a Bunsen burner. Start heat it up, or put it on top of your stove and start heating it up very rapidly. Is the temperature of the water going to increase? No. The temperature of the water will stay at 32 degrees, at the freezing temperature of water, until all the ice melts. The first thing that happens is all that heat goes into melting the ice. And the water maintains a stable temperature of 32 degrees. This is, this is kind of physics class 101, but, if you never took the class, this is how it works. It's called phase change, right? Solid, liquid, gas, these are called the phases of a compound, in this case, of water. And when water is solid as ice, it has to be below 32 degrees, and so it will hold all of that heat will go into melting the ice. Now, minutes after the last ice cube melts, the water in that glass starts heating up really rapidly. Now, shift that from your glass with your Pyrex beaker with your water and ice in it into the Arctic Ocean, which is covered with ice, or was covered with ice. And now, giant areas of it no longer have any ice. And the ice that is growing in the winter, see, typically the ice grows in the winter, it recedes in the summer, but it doesn't recede that much. It used to be in the summer, you could walk across the ice to the North Pole. Well, you can't anymore. North Pole is now just water. In fact, a cruise ship went across the Arctic Ocean just a few months ago, at the end of the summer. And the big danger here is that if that methane gets heated up, we have, from the time of the Industrial Revolution until recently, we have burned around, the number I always used to use was 500 billion tons of carbon, but I think it's closer to, Troy, you've been researching this. Is it 800 billion tons, more or less? You're not, how much carbon have we burned since the 1850s into the atmosphere? 555 gigatons? Okay, thank you. So we've burned about 555 billion tons of carbon into the atmosphere. And it has produced almost 2 degrees of warming. We're beyond 1 degree now, and we're heading toward 2, and it's unlikely anything's going to stop that. And if the last of that ice in the Arctic melts, so that the water then begins heating up beyond 32 degrees, it has the possibility of melting that methane. which represents 1,500 billion tons of carbon. Whether it goes into the atmosphere as methane, whether it gets converted to carbon dioxide by bacterial action or even chemical action, it's still carbon going into the atmosphere. Now, methane is far more, it's 80, 90, 100 times more potent a greenhouse gas than carbon dioxide, although it only lasts about 20 years. But if you look at the major extinctions on Earth, all of them seem to have been, at their very worst, punctuated by a sudden pulse of methane into the atmosphere, because these methane hydrate crystals, these methane clathrate crystals, frozen methane around the continental shelves all around the world, has the sea has warmed up enough that methane warmed up, that boom, it goes into the atmosphere, and so you get this sudden 5-degree spike, 5 or even more degrees Celsius spike in temperature worldwide, which then produces, firestorms and massive extinctions. I mean, in the Permian, it was 97% of all life on Earth went extinct. It was hundreds of millions of years before anything larger than a mouse returned of any consequence. And now comes this story. This is from Science News, sciencenews.org. For 3 years in a row, Earth breaks heat record. It's by Thomas Sumner, published January 18th, 2017. For the third year running, Earth's thermostat broke a new record. 2016 was the warmest year since record-keeping began in 1880. Spurred by climate change and heat from a monster El Nino, the global average surface temperature last year was 0.94 degrees Celsius higher than the 20th century average. It's almost 1 degree. It's 1.69 degrees Fahrenheit. That slightly edges out the previous title holder, 2015. 8 months during 2016 set all-time highs, including July, which was Earth's warmest month on record. Scientists from the National Oceanic and Atmospheric Administration and NASA reported January 18th. This is only the second time that the annual temperature record has been broken 3 years in a row. And the last time was 1939 through 1941, and it didn't even rank in the top 30 warmest eras. So it was just, kind of a coincidence. But if you look at the ice, the Arctic ice from 1978 to 2017, 2016 and 2017 are really, really, really scary lines. We're talking about the possibility of the extinction of life on Earth, including us. And yet this is a topic that our news media saw fit not to even bother with in any of the presidential debates. Never made its way into the dialogue outside of Bernie Sanders, frankly, talking about it pretty aggressively. This is an existential threat to the survival of the human race. Not just to cities on the coasts, not just to civilization, to literally the survival of the human race and everything larger than a mouse. We're talking a massive threat here. And Donald Trump wants to put Scott Pruitt, the guy who works for the oil industry, as the Attorney General for Oklahoma, wants to put him in charge of the EPA. I mean, it doesn't get any more bizarre than that. It doesn't get any more, frankly, dangerous than that. Now would be a really good time to call 202-225-3121 and say to your senators, particularly if they are Republicans, and say to your 2 senators, no, we do not want a shill for the oil company running the EPA. We don't want it. No. We'll be back.
This is the Thom Hartmann Program.
By the way, at 1 minute after noon on last Friday on inaugural day, all mention of climate change vanished from the White House website.